Hi class, here are some particle to mole conversions. So an important thing to remember is that in order to convert something we need a conversion factor. So here's ours. 1 mole is equal to 6.022 times 10 to the 23rd particles. And so if I know how many particles I have, I can convert them to moles using this conversion factor. So let's try the first one. Here I have 2.53 moles of lithium. So I'm going to start off by writing my given number. So here I have 2.53 and I have that many moles. And I'm just going to write MOL because that's how we abbreviate moles. What I'm going to do is I'm going to multiply this by a conversion factor. So the thing that I want to go to goes on top. So my 6.022 times 10 to the 23rd power is going to go on the top. I'm trying to write this a little bit faster. And then my 1 mole goes on the bottom because the thing that goes on the bottom is going to cancel out. I'm just going to write P for particles so I can move a little bit faster. And then on the bottom, I have 1 mole because that's how many moles there are in one particle. Or excuse me, in how many there are in 6.022 times 10 to the 23rd particles. So when I plug this into my calculator, what I have to make sure is that you usually want to put this number in parentheses. Just the number, not the words. The words don't go in your calculator. But if I multiply this across and then I divide by that, it's the same as just multiplying this times that. And so when I do that, what I get is 1.52 times 10 to the 24th products. Now, none of these numbers seem reasonable because these numbers are so large. They're bigger than any number that we've ever thought of. So how do we know whether or not particles of lithium? So I'm just going to say atoms or particles of lithium. So how would I know whether or not this is a reasonable number? And the way that you would check is I'm going to give you like is it greater than 6.022 times 10 to the 23rd particle or smaller? So if I had 1 mole, I know that I would have exactly 6.022 times 10 to the 23rd particles. So how can you solve that? Well, I can ask, is this number bigger than 1 mole or smaller than 1 mole? So 2.53 is bigger than 1 mole. So I would expect my number of particles to also be bigger than 6.022 times 10 to the 23rd, which it is. And this is a little bit bigger than that. This number is a little bit bigger than that. And so this answer is reasonable. All right. For the second one, I'm going to do the same thing. I'm going to set up my problem here, and I'm actually going to give you guys a minute. So if you're watching this video, I would say pause it for a second and work on it on your own, and then we'll go over the answer. So I'm going to count 3, 2, 1, and we're back. So this is after you've paused and worked on it yourself. I have 0.874 moles. And this is of FeNO3. I'm going to write that out, FeNO3. So what you'll notice is usually the thing that we're talking about is just one thing. So it probably won't seem that important now, but later on when we're doing stoichiometry, we're going to have a reaction, so we're going to have multiple things becoming different things, and so it's going to matter a little bit more. And I'm going to multiply this by the thing that I want goes on top. So 6.022 times 10 to the 23rd particles goes on top. So I'm going to write in there 6.022 times 10 to the 23rd. And then my number of moles will go on the bottom. Again, just please make sure that you're typing this correctly into your calculator. If you have any issues, please let your teachers know, and they can help you solve that, or ask a friend, I guess, would also be helpful. But sometimes you have different calculators than the ones we use in class, or different than the one that your friend uses. And more than anything, we want to know that you know how to make sure that you know how to use the calculator that you're using during an exam. So when I do this, I have this many particles again. I'm just going to put P in there for particles. and I'm going to get 5.26 times 10 to the 23rd power. So what we want to do is we want to know, this would be technically formula units, which are FUs. Formula units is how you abbreviate that, of FeNO3. So what we want to do here is we want to know, how do I know if I'm doing this right or not? And the way that you would know, and I'm going to try and squeeze this in here. The way that you would know is by kind of like checking, does this number sound reasonable? Now this number doesn't seem reasonable to anybody because look at how big this number is, right? This is like a trillion times a trillion times a trillion. So this number seems really, really big. So how do I know if it's reasonable? Well, here I have less than a mole. Here I have 1 mole. We know that 1 mole is equal to 6.022 times 10 to the 23rd particles. It's called Avogadro's number, actually, named after the person who kind of figured this out. So what I want to know is if this number is less than 1 mole, well, then I would expect this number to be less than this many particles. And in this case, 5.26 times 10 to the 23rd is a little bit less than 6.022 times 10 to the 23rd. Right? If this was 6, then they would be the same, but this is a little bit less at 5. So this is actually less. So this seems like a reasonable number. All right. Hopefully that has helped. Good luck.